Hey everyone, so in this video we're going to be covering 10 of the most important and common question types that you need to know for the SAT math exam. Now, if you want 50 plus SAT math questions, we have a playlist I'll link down below. As always, try the problems on your own before watching the solution, and good luck on your exam.
This one says, in the given equation, b is a positive integer. The equation has no real solution. What is the greatest possible value of b? So they give us a quadratic equation, negative x squared plus bx minus 676 equals 0. So in order for us to solve this problem, we need to calculate what is called the discriminant. So the discriminant is what you're going to find in that quadratic formula. So that is square root of b squared minus 4ac. All right, so if you didn't know, the discriminant determines the number of solutions a function has, or a quadratic function has. So if this value is positive, that means it has two solutions. If it is negative, then that means it has 0 solutions. And if it's equivalent to 0, that means it has one real solution. So in order for us to calculate this, we just need to know what the this part right here, the negative 4 times a times c is equivalent to, and then just find a b value that is less than that, but the greatest possible value. I'll show you how to do that. So let's first calculate negative 4 times a, we know our a value is negative 1, times c, our c value is negative 676. And this will give us a value of negative 2,704. All right. So as we talked about before, we need to know that the value of b squared has to be less than 2,704, but it has to be the greatest possible value. So what we can do is just set b squared equivalent to 2,704. Not negative 2,704, because this has to be a positive value in order to be subtracted, right? And so now we're just going to solve for b. So if we take the square root of both sides, we're going to get b is equivalent to the square root of 2,704, which is oddly equivalent to a odd number, whole number, which is equivalent to 52. Now 52 is not our final answer, because if b is equivalent to 52, our discriminant would be equal to 0, and we would have one solution. But this equation has no real solution. And so we know that b is a positive integer. So in order for b to be a positive integer, it is just the number that is below 52. So the next closest value under 52 would be 51. And so the greatest possible value for b is 51, because if we can test this, 51 squared is 2,601. And that is indeed smaller than 2,704. And so if you did the math there, you would get a negative value. And so the discriminant would have a negative value, meaning you would get no solution. And that would ultimately solve the problem. And this problem says that the circle above has a center O. The length of arc ADC, the minor arc, is 5 pi, and x equals 100. What is the length of arc ABC? All right, so if we look at this, what we want to do is set up a ratio, right? So the first thing we know is that the angle x is going to be corresponding with that arc ADC. So our angle x, we can just write this on top, would be 100, right? And so it's corresponding to arc ADC, which has a length of 5 pi. And so now they want us to determine what is the length of arc ABC, right? This side right here. This side right here, right? So because we know that the circle is split up quite evenly, right? The degree value over here is going to correspond with that arc length of ABC. And so can we determine that angle? Well, we can't, because we know there's 360 degrees in a circle. And so if angle x is 100 degrees, we're left with 260 degrees, right? So this will go on top. And so now we can actually pretty easily figure out what our length of arc ABC is by just finding this corresponding value, right? So to do this, we have to do some simplification, or we can just find the factor actually, right? So from 100 to 260, that is a scale factor of 2.6x, or 2.6 times. And so we can assume that for the same thing on the denominator, to keep this ratio constant, we also have to multiply this by 2.6. And so here we can just do 5 times 2.6 pi. And that's the same thing as multiplying 5 pi by 2.6. So 5 times 2.6, that will give us 13, right? And then we can just add the pi at the bottom, or next to it. So we get 13 pi as our final answer. It says for the linear function f, the table shows 3 values of x and their corresponding values of f of x. Function f is defined by f of x equals ax plus b, where a and b are constants. What is the value of a minus b? All right, so they give us, it says they give us 3 values of x. And so what we can do is actually make the function, right? Let's plot it out. So we have f of x, and so now we have to find out what the slope is. That's what the a represents because it's right in front of the x. All right, so to find that, we just want to look at the difference in between. So it's rise over run. So from negative 64 to 0, that's the increase of 64. And from 0 to 64, that's an increase of positive 64 as well. And we can see for that each positive increase of 64, so that's a change in y, our change in x is just plus 1, right? So we can determine that our slope is 64x. All right, so now we want to determine b. So b is the y-intercept. And so the y-intercept is the value you get when x is 0. Now it's not on here, but we can predict what it is. So we know that the difference between 1 and 0 is a x value of 1, right? So plus 1 here. And so we can just work backwards. So instead of adding 64, we can just subtract 64. And so here, minus 64, we'll get a value of negative 128. And so our x-intercept would be 128. So you could write this as plus negative 128, but it's the same thing. So it says, what is the value of a minus b? So our a value is 64, right? And it's subtracting the b value. The b value is negative 128, right? So if you subtract a negative number, we're essentially adding it. And so 64 plus 128 is just 192, so that's our final answer. In the given quadratic function, a and c are constants. The graph of y equals f of x in the xy plane is a parabola that opens upward and has a vertex at the point hk, where h and k are constants. If k is a negative, because it's under 0, and f of negative 9 equals f of 3, which of the following must be true? And they give us 2 clauses. So the first thing I want to point out is, just write this, and let me use another color, I'll use purple. So it says that the parabola opens upwards, right? So a parabola that opens upwards means the a value has to be positive. Now the second clause here does satisfy that, except it's not accounting for those values like 0.5, right? Like 0.5 is still a positive number, but it's just not equal to or greater than 1. And so we can't really verify the second clause unless we solve it mathematically, and we can't because they give us this information, f of negative 9 equals f of 3. So the standard equation they give us is ax squared plus 4x plus c, right? And they give us the x coordinates basically. So we can plug in negative 9 for x, so negative 9 squared is 81. And we'll just say 81a because we're solving for a, right? Plus 4x, so 4 times x would just be negative 36, so plus negative 36 plus c. And what you'll realize here is we'll set this equal to f of 3. So if we plug in 3 for x, we get 9a plus 12 plus c. So this is the interesting part, is that the c's actually cancel out on both sides. And so now we're just left with one variable, and that one variable is a. And so we can solve for a. Let's add 36 on this side and subtract 9a on that side. So we get 72a equals 48. Divide both sides by 72. We get a equals 48 over 72. So therefore, we can actually eliminate that second clause because that is not true. A does not have to be equal to or greater than 1. We just proved here that the A value is a decimal value. It's positive. It's under 1, but it's still positive. So now what we need to do is prove the first clause, right? So is this first clause true? Well, we already have the standard equation here, and we know the A value, so let's just write out what we know. So we have 48 over 72, x squared plus 4x plus c equals something. So the problem here is we have too many missing variables, right? We need a value to plug in for x, except we don't know c, so we can't find whatever the outcome is, the y value. But what we do know is that they've given us this information. K has to be a negative. What is k? K is the negative, K is the y coordinate of the vertex, right? And so the vertex has both x and y coordinates, and so h. What is h? H is the x coordinate of the vertex. So if we can find the value of h, we can plug it into this equation down here and see if the generalization is true to solve for c. So how do we find h? Well, it's actually pretty interesting because the parabola is symmetrical, right? And we know these two, f of -9 and f of 3, they're equal to each other. They have the same y coordinate values. And so their corresponding x coordinate values are going to be equidistant away from the vertex. And so what we can do is just do -9 plus 3 over 2. We're just finding the middle of those x coordinates. So this gives us -6 over 2. That's -3. So now we have the h value, the x coordinate of the vertex. So we can plug this -3 into our equation. So we have x squared, so -3 squared times 48, 72. And then plus 4 times -3 would give us -12. Plus c, we don't know what that is equivalent to k. We know k has to be negative. Let's keep that in mind. So this would be 9. -3 squared is 9 times 42 over 72. That'll give us 6. Oops. That'll give us 6 plus 12, -12, so just -12, plus c equals k. So this simplifies out to a value of -6 plus c equals k, or c minus 6 equals k. So let's see what the clause says. So it says the restriction is that c has to be a negative number. Now, is that true? Well, if we were to plug in a negative number for c, let's say on a pick and random, like -3. -3 minus 6 equals -9. Well, -9 is a negative number, and we know k has to be a negative number. However, if we plugged in a positive value for c, would this equation work? Well, if we plugged in, let's say 5 minus 6 is -1. Well, now c is a positive number, and we still got a negative k, which means that the first clause right here is not true. So boom, boom, boom. First clause, not true. A lot is going on the screen, but the answer is going to be D. Point O is the center of the circle above, and the measure of angle OAB is 30 degrees. All right, so that's going to be 30 degrees right there. Boom. If the length of line segment OC is 18, so this is 18, what is the length of arc AB? So I think this is the minor arc of AB right here. Well, the first thing to note here is that OC represents the radius, right? Or the radius. So because OC is the radius, right? Because it goes from one point on the circle to the center, we know that the radius has a value of 18. Now, the same thing happens from B to O, and as well as A to O. And therefore, we know that the sine length of AO is going to be 18. So let me write. Is 18, and the sine length of BO is also 18. Now here's what's interesting, right? Because these two sine lengths are equal, right? We know they're opposite angles. The angles opposite to them are also going to be the same, right? And so if this right here, the 30-degree angle is opposite of 18, we know that this angle right here is also going to be 30 degrees. And it's kind of funny because now we have a isosceles triangle, right? So it works out in the end. So this angle right here we can conclude is 120 degrees. Boom. All right, so now how do we actually solve for the length of AB, right? Well, here's the thing. We know that AOB, that angle, the 120 degrees right here, that is the inscribed angle of the arc of AB. So technically speaking, the length of the arc is 120 degrees. However, we want to express it in first off radians, and also it'll be based on the circumference of the circle, right? So first off, let's just find the circumference of the circle. So the circumference of a circle is equivalent to 2 pi times radians. And therefore our radians, the radius, not the radians. So the radius is equivalent to 18, right? So we can just do 2 times 18 is 36 pi. And so that is our circumference, all right? And so in order to calculate the length of the arc, what we can just do is first just find the ratio to scale it up. So we have 120 degrees over 360. So that in reality in itself is just 1/3, right? So what we want to do is just take 1/3 of that circumference. And so 1/3 of that circumference, which we know the circumference is 36 pi. So 36 pi, let's just divide this by 3. Because we know that this angle represents 1/3 of it. And so we can just do 36 over 3, which is 12, and keep the pi, so we don't have to simplify it completely. And so our final answer here is going to be an answer of 12 pi, and let's see, it does match up with answer choice B, and therefore that is our answer. Ken is working this summer as a part of a crew on a farm. He earned $8 per hour for the first 10 hours he worked this week. Because of his performance, his crew leader raised his salary to $10 per hour for the rest of the week. Ken saves only 90% of his earnings from each week. What is the least number of hours he must work the rest of the week to save at least $270? So first off, let's just set up our inequality, right? So he needs to save at least $270, so, right? 270. And so he can save more than 270, but he needs to save at least 270. So greater than or equal to, and then his savings, it says right here, he saves only 90% of whatever he earns, right? So whatever we have with his $8 per hour or $10 per hour for X amount of hours, right? All that is going to be cut down by 90%. So we can write a 0.9 on the outside and then a parentheses for all of our values on the inside, right? So the first thing we want to account for is his initial 10 hours that he worked. So he worked that initial 10 hours at a rate of $8 per hour, right? And therefore, since he worked 10 hours at $8 per hour, he made $80. So we just write a flat $80 right there. But then his performance increased, right? And therefore his salary also increased. It says his crew raised his salary to $10 per hour. We don't know how many hours he's going to work at $10 an hour, but we know that he must work a certain amount of hours to make at least $270. To save at least $270. Therefore, we can write this as plus 10, because that's the flat rate. And then we can just write X as the number of hours he works. And X in our case, in this inequality, will represent the least number of hours he must work to save at least $270. All right, so now we just want to simplify this inequality, right? So 0.9 times 80 is going to give us a value of 72. 0.9 times 10x is going to be plus 9x. Set this equal to greater than or equal to 270. Okay. And so we want to subtract 72 from both sides because we're isolating for x. And so we get 198 is less than or equal to 9x. Divide both sides by 9 and we get a value of 22 is less than or equal to x. All right, so what does this represent? Well, this means that in order to save at least $270, they will have to work, or who's there? Ken will have to work at least 22 hours, right? But this also means that, if he works greater than 22 hours, he'll save more than $270. But we just want to find the number of hours that it'll take him to save at least 270 hours, working the least number of hours, right? And the least number of hours in our case is right here, 22 hours, because that's the minimum that he has to work. And therefore, our answer choice is going to be C. Adam's school is a 20-minute walk or a 5-minute bus ride away from his house. The bus runs once every 30 minutes, and the number of minutes W that Adam waits for the bus varies between 0 and 30. Which of the following inequalities give the values of W for which it would be faster for Adam to walk to school?
Right, so the first thing you notice here is that for all of our inequalities, everything on the right side is a constant 20, right? So that represents that 20-minute walk that Adam has the option to take. Everything on the left side, therefore, represents that bus ride. So it's the 5 minutes of the bus ride from his house to the school, including that waiting time from between 0 to 30 minutes. So if we want the inequality that shows that it's faster for Adam to walk to school, that means that 20 minutes is going to have to be less than whatever's on the left side, because then that shows that it takes less time, right? So first off, we can eliminate two answer choices because these don't show that relationship. So the first one is A, and then the second one is C, right? These show that 20 is greater than the left side, which we don't want. And now we're down to B or D. Well, the thing with B is it shows W minus 5. In reality, this doesn't really make any sense because that 5-minute bus ride is included in the waiting time, right? So the waiting time here is W, the amount of time that Adam has to wait for the bus. And so we want to add on that 5 minutes because it takes 5 minutes to actually get on that bus from his house and actually arrive at school. And therefore, it can't be minus 5 because we're not taking away time, that's just adding time to him. And therefore, our answer is going to be choice D. A shipping service restricts the dimensions of the boxes it will ship for a certain type of service. The restriction states that for boxes shaped like a rectangular prism, which I've drawn one out here, it's a pretty good drawing actually, the sum of the perimeter of the base of the box and the height of the box cannot exceed 130 inches. The perimeter of the base is determined using the width and length of the box. If a box has a height of 60 inches and its length is 2.5 times the width, which inequality shows the allowable width x in inches of the box. All right, so first off, let's label our diagram, right? So we know the height they give us is 60 inches, so let's just write 60 out here. Oopsies. There, 60. And then they also give us the width, which is x. Well, we don't really have a value for x, so we'll just label x out here. We know the length is 2.5 times the width, so we just write this as 2.5x, right? And now what we need to do is set up our inequality. So let's use green and write out 130, because it cannot exceed 130, right? And therefore, I'm going to write up the sign like this. But it can be equal to 130, it just can't exceed 130. All right, so now we need to find what the restriction actually is for the 130 inches, right? Well, it says right here, it's the sum of the perimeter of the base of the box and the height of the box. And so the height of the box, first off, we have a value of 60. So we have 60, and it's the sum. So we're going to add this to whatever we have with the perimeter of the base of the box. So the perimeter of the base of the box is just that base, that one side, right? So that one side, we're going to have that length and that width. However, there's that other side. I'm trying to make the drawing. So this is a three-dimensional object. So you have two widths in reality, right? So you have a width on this side right here, and you have a width on the other side. And the same thing with the length, right? So you have 2.5x on one side and 2.5x on the other side. And therefore, when we write our inequality to find the perimeter of that one, side, we can just double the addition of both the length and the width. And so we can write this as 2 times 2.5x plus x. All right, so now what we want to do is just expand this out. So 2 times 2.5x will just give us 5x. And then 2 times x is going to be 2x. And so we get 7x over here. So in our equation, we're going to have 60 plus 7x, and that is going to be less than or equal to 130. And now we can just solve for x, right? Because x is going to be that width that we're trying to solve for. And so we can just subtract 60 on both sides, and we get 70 is greater or less than 7x. Divide both sides by 7, and we get x is less than or equal to 10. So we get this inequality over here, and we want to match it up to the answer choices. So let's look at our answer choices. So for A, we have x is greater than 0, but less than or equal to 10. Well, that actually lines up exactly with our equation, right?
for all these inequalities, the minimum or x has to be greater than 0, which makes sense because you can't have a width of 0, right, for a box like a rectangular prism. And therefore, since this part of the inequality matches up with what we have down here, it's the same thing but flipped, our answer choice is going to be A. In the given system of equations, h is a constant. If the system has no solution, what is the value of h? All right, so if the system has no solution, that means the lines will never intersect. And we can see here we're dealing with linear lines. And so linear lines that never intersect are going to be parallel lines. And we know parallel lines have the same slope and different y-intercept. So in order to do that and find the corresponding values for the constant of h, what we need to do is first put these equations into slope-intercept form. So the top one right here, what we can do here is add 9y to both sides, and then we want to subtract 5 from both sides, just so we can isolate for y. So we have 18y equals 4x minus 5. And now for slope-intercept form, this will just simplify. We divide both sides by 18. So y will be equivalent to 4, 18, x minus 5 over 18. All right, so this is our equation, right? That means what we need to do is get this equation, the second equation right here, to have the exact same slope of 4 over 18, but a different y-intercept. So let's see if we can do that. So we have hy equals 2 plus 4x. So let's zoom in on this slope, right? The current slope is 4, as a value of 4. Let's just ignore the x for now. So the current value of 4 is much more different versus the slope that we want, which is 4 over 18. So how do we go from 4 to 4 over 18? Well, we can do this by just multiplying 4 by 1/18. And therefore, that will give us 4 over 18. And so how do we multiply 4 by 1 over 18th? Well, that's the same thing as dividing 4 by 18, right? And we know that in order to divide this 4x, the h value will have to represent that, right? So let's say h was 18, then 4 would be divided by 18 when you isolate for y. So I'll show you how this works. So if h was 18, then we get 18y equals 2 plus 4x, right? And so now when we isolate for the y value, divide both sides by 18, we get y equals 2 over 18 is 1/9 plus 4 over 18 x. And so now we have our two equations, right? We have this equation and this equation. We can clearly see that they have the same slope of 4 over 18, right? But they have different y-intercepts as we wanted before. So this one has a y-intercept of negative 5 over 18. This one has a positive y-intercept of 1/9. This is messy. But because of that, we know the constant h is going to be the letter D, 18. Figure AC equals CD, okay? And the measure of angle EBC is 45 degrees, so let's label that. Boom. Okay, and the measure of angle ACD is 104 degrees. What is the value of x in degrees? So the value of angle AEB, that's what we're trying to find. So the angle of AEB. Okay, so how I like to approach, just geometry problems in general when you're trying to find an angle is just, don't try and take it in all at once. Just take it step by step, break it down, see what angles you can find, see what theorems you can implement, and eventually, you never know, you might find the answer from that. So first off, they tell us that AC equals CD. So this triangle right here, triangle ADC, this is a isosceles triangle, right? Because these two side lengths are equal, then we know that these angles here, angle D and angle A, are going to be equal to each other. Because there's only 180 degrees in a triangle, and we know angle ACD is 104. I should add events. Boom, boom. So that gives us 76 degrees between those two angles. And so we can divide that in half and we get 38 degrees. So we know each of these angles, so angle A is 38 degrees and angle B is also 38 degrees. Okay, so that's one step of the puzzle. So how exactly can we find angle this X, right? So one way I'm looking at it right now is it's on this line right here, and we can use what's called the supplementary angles, right? Because two angles on a straight line will have to equal 180 degrees. So if you find this angle right here, angle DEB, whatever that is, if we find that value, then we can just subtract 180 minus that value, and then we get whatever X is going to be. So is there a way to find angle DEB? Well, it's actually pretty interesting because they gave us the measure of EBC, this angle up here, and we just figured out the angle of BDE. And so these two angles make up a portion of this triangle, right? So it's this triangle right here. Boom, boom, boom. Oops. This triangle. All right. So we know there is, let me just switch back. There is 180 degrees in a triangle. So if we found two of the angles, 45 degrees and also 38 degrees, then we can find the last value. And this last value, let's do some quick maths. I think that is 97 degrees. Okay, so angle E is 97 degrees. All right. All right, so as we said before, now we can use supplementary angles. So we know these two angles, this angle we just found here, 97 degrees, and angle X, together they will have to equal, so 97 degrees plus X, whatever that is in degrees, has to equal 180 degrees. And so we can do some simple maths. 83 is our final answer. So the value of X would be 83 degrees. And I think they want you to represent it as just the value without the degrees because they already state the degrees here. And so if you're really finding X, the actual answer is just 83. So yeah, there you go. That's the answer. And thank you guys for watching. I hope you learned something.